this is where we left off in our last video. Uh, so we've seen some of those might be easy to memorize, some of them may not. Okay, for example, if we have something like this, that is so close to this, right? It's only off by some constant, but this involves a lot of algebraic manipulation to make this 1. All right, so you'd have to factor out, you could think about it as factoring out a 4, right? Because then it's this. And now we have this as our function instead of x squared. It's a lot of work. All right, so as a shortcut to work, you need to just memorize certain things. All right, so this is, if you can think about it as, if you see on the denominator a number squared minus a function squared, and the derivative of that function is right up top, you can use this formula to help you out. All right, if you have a number squared plus some function squared, a number squared plus a function squared, and the derivative of that function's up top, you can use this formula to help you out. Okay, and similarly with the arcsecant. Now the arcsecant, that's a little bit of work, but we'll get there. All right, so some of these are going to involve trig, and some of them aren't. So we'll look at this first one. Does this look like any of those? Well, I have a number squared minus a function squared, all right, and the derivative is close to the top. So if I let a equal 2 and let u equal x, all right, now dx would be just 1 dx, so we're fine. All right, so now this is strictly what I was talking about before. Just memorize it. Arc sine, or inverse sine, whatever one you want, of u over a. So x over 2 plus c. It's not too bad if you memorize those. All right, this one looks similar, right? We have a number squared minus a function squared, but we have that darn x in the front. So I'm going to rewrite this. Maybe as I'm rewriting this, some things will start appearing in your mind. All right, I'm going to even rewrite it a little bit more. So using U-Substitution or pattern recognition, you should recognize that x is the derivative of this inside function, but it's only off by a constant. The derivative of the inside would be -2. So I have to correct for that by multiplying by -1/2. All right, now, oops, I forgot to put that 1/2 here. Now it's just a power rule. So we have this, add 1 to the power. That would be 1/2, divide by the new power, 2. Plus c. All right, and then if you want, you could rewrite it back in that square root form, but you don't have to. Doesn't matter. All right, let's try the next one. Does this look like any of the patterns we have above? It sure does. If a equals square root of 2, all right, and u equals 3x, then we're pretty darn close to having this look like the arctangent one, except for we're off by a factor of 3. So I'm going to correct for that by putting 1/3. Then I'm going to use that formula there for arctangent. 1 over a times the arctan of u over a plus c. There you go. And if you want to combine that, you can. I'm not going to waste my time. All right. Does this part D look like any of those? No, but it does look like something that we can do. All right. If I write it like this, x times 1 over 2 plus 9x squared. Now, I know x is close to the derivative of this. I'm just off by a factor of 18. So I need to correct for that. 1 over 18 times, now I wouldn't use the power rule here because that would be a power of -1. I'd use ln 2 plus 9x squared plus c. All right, so sometimes when you have these quotients, it will be inverse trig, and sometimes it won't. So you have to be flexible enough with your integral abilities to hit any of these. Now the arcsecant, let's leave it at that. All right, so in this one, if you use this, I'm going to pull out, there's 9/5, the 9 and the 5, because I don't want to have to think about it. All right, so I have 1 right now on the top, or I could write my dx up there, save a little space. X times x squared minus 16. All right, so this looks like that arcsecant formula, okay, right up top. If we allow a to equal 4, u to equal x, we have dx, we're good. So now it's just 9/5, and it's applying that rule. So that rule is 1 over 4 arcsecant absolute value of x over 4 plus c. There you go. All right, that one wasn't so bad. This one. All right, so think about it as your inside function, this time being 2x, and this would be minus 3. All right, so we need that same function, the u, on the outside. So I'm going to write it in this time, all right? If that was a 2, we'd be fine. I'll put a 2 up here to keep it consistent, all right? I didn't change my function because I just put a 1 there. All right, now this up at the top is the derivative of my u. I can just apply the formula here. So 1 over 3 arcsecant of, and I had absolute value 2x over 3 plus c. All right, one more. If I allow my u to be e to the x and my a to equal 1, all right, and I'll put that e to the x up there. The derivative of e to the x is just e to the x. So right now, this one didn't even look like this. All right, it was missing these parts. But secretly, it is there because e to the x over e to the x, that is just 1. All right, so now we just apply this at 1 over 1. I'll write it for now. All right, arcsecant of absolute value e to the x over 1 plus c. All right, but really I didn't need absolute value. E to the x is always 1. I mean, always greater than 0. Okay, there you go. Not too bad, not too bad. All right, on to our next example. 17. Sometimes we have to do a little bit of work to make something look like something we can use. All right, so this comes from doing lots of problems. The more you practice, the better you will be at this. I see that that darn 2 is messing it up for me, or you could think about maybe that x is messing it up. All right, so I'm going to break this up into 2 separate integrals. All right, so my first one, I can just use my pattern recognition. All right, and I'm going to rewrite it one more time. This time I'm going to rewrite it as 4 minus x squared to the negative 1/2. This one, I'm going to just pull that 2 out in the front, and I can recognize this using my, sorry, I can't talk and write. All right, using one of my inverse trig things. So this part, this is the derivative of the inside, but it's off by a factor of negative 2. So I'm going to multiply by negative 1/2. Okay, now this is just the power rule, 4 minus x squared. Add 1 to the power, positive 1/2, divide by that new power, times 2. Okay, plus, oops, don't want to put that plus c yet. I'm going to put it at the end. Oh, okay, there we go. Okay, so now the other one, I'm going to put plus 2. Well, that's just arc sine, but with a equal 2 and u equals x. All right, so arc sine x over 2 plus c. All right, see, that wasn't too bad of a problem, and now that's something we can handle because we know both of these types of problems. All right, 2 of these 3 you can do, and 1 you cannot. All right, let's try to see. Maybe we can do the first one. Pull that 3 out. I'm going to write it like this. And that's negative 1/2. There we go. Now I recognize that the derivative of negative x to the 4th, that's going to be negative 4x cubed. So I'm only off by a constant, so I can go ahead and use that power rule. So now I'm going to take this and add 1 to the exponent, divide by that new exponent, and put my plus c. There you go. All right, so this one, well, this kind of looks like the arc sine one, right? We let a equal square root of 5. We let u equal x squared. Now is du should be 2x. Oh man, that darn 2. If that wasn't there, we could do this. All right, so this is something that we cannot do yet. All right, that's always a fun word, right? So here we have this one. It is what I wanted, so I'm going to let a be square root of 5. I'm going to let u be x squared. Then du, okay, that would be 2x. So I'm missing, I'm going to pull the 3 to the front, this 3, pull it to the front. I'm missing that 2, so I got to correct for it. And now I'm just going to use my formula here, which is just arc sine u over a, which would be x squared over square root of 5, and I'm not going to forget my plus c. All right, so that wasn't too much of a problem. And let's see. Yeah, I think we could do one more problem. It shouldn't be too bad. Now, this one. We can't just use that bottom function because we don't have the 2x plus 6 on the top. This isn't anything with our inverse trig, so we have to develop some other patterns, but maybe not. You can recognize that can be factored into x plus 3 squared. And then if you recognize that, pull that 3 out to the front. This is the same as x plus 3 to the negative 2. And so we just use the power rule. Okay, add 1 to the power, divide by the new power, plus c. And so if you want to rewrite that, negative 3 over x plus 3 plus c. So not too bad. All right, this one is a little bit different. It almost factors. And maybe because we did that first problem, you'd recognize that we could write it like this. Then it would factor. Okay, so then we end up with 3 over x plus 3 squared, quantity squared, plus 1 dx. So that's a function squared plus a number squared. All right, so I'm going to pull that 3 out. A would be x, well, A would be 1. U would be x plus 3. That's our arctangent. That's our arctangent. So we have 1 over A times arctan or inverse tan of, okay, u over a. And we don't want to forget our plus c. So I'm just going to rewrite that so it looks a little nicer. 3 arctan of x plus 3 plus c. Not too bad. All right. Now, if you didn't recognize this, you can use something that we did in pre-calc. Maybe you did it before, called completing the square. All right, so we have this. We're going to have x squared plus 6x plus something, okay, plus something else. So you take half of this constant, divide by 2, all right, so 6 divided by 2 is 3, then square it. So you add 9, and so then you also have to add negative 9 to cancel that out. All right, so for example, we're going to take this x squared plus 6x. I'm going to leave the plus 8 over there. So half of 6 is 3. Squared is 9, so I'm going to add 9 and subtract 9. So this would factor into x plus 3 squared minus 1. All right, so then if we had something like this, x plus 3 squared minus 1, does that match any of our functions? No. Well, maybe we could do something else then. All right, let me erase that. Maybe we could do something else. Maybe it factors, and it factors nicely. So that would be 3 over x plus 4x plus 2. All right, that looks good, but now what do we do with it? All right, and at this point, this isn't something that we can do. You'd have to use something that you would use in Calc 2 or if you took AP Calc BC called partial fractions. And we're not ready for that. If you want to learn, I can show you after the AP exam. Alright, so we're going to stop this video here and pick up with the rest later.